Dear students, in this lecture we are going to start a photo reduction point. This is the last point of this topic. So this photo reduction, the example is conversion of benzophenone to benzphenacol. So benzophenone is converted into benzophenacol. So this is a reduction reaction. If you see this reaction, see here, I will read the first statement and we will discuss about the reaction. So benzophenone undergoes photochemical reaction, reduction reaction at 330 nanometer in presence of isopropyl alcohol to form benzphenacol. So in this case, this reaction is carried out at 330 nanometer and the isopropyl alcohol is used here to convert, to reduce this molecule, that is benzophenone, into the benzphenacol. If you see this reaction, two molecules of benzophenone are used here. Two molecules of benzophenone are used and isopropyl alcohol is there, and in presence of radiation it is converted into benzphenacol. So in this case, what is we will discuss about what is the role of this isopropyl alcohol in this reaction. See this mechanism point, the first Roman. The reaction takes place in triplet state. So this reaction takes place in the triplet state and involves abstraction of hydrogen from isopropyl alcohol to give a benzophenone ketal radical. So in the first step, if you see this mechanism, the benzophenone abstract proton from isopropyl alcohol and it is converted into a benzophenone ketal radical. In the next step, the radical of isopropyl alcohol again transfer another hydrogen atom to the second molecule of benzophenone in the triplet state to give another benzophenone ketal radical, and then these two ketal radicals gives a benzphenacol by combination reaction. I will explain what exactly the meaning of this mechanism statement. Now see this reaction here. In the first step, what happened? So this is the benzophenone which is in the ground state. When it is exposed to a light, the double bond between this carbon and this oxygen is get splitted. So homolytic fusion takes place. So this carbon carries one radical. This oxygen now has a radical. So this is in the singlet excited state. After intersystem crossing, this molecule it transfers to the triplet state. So now this molecule has radicals at this carbon and this oxygen. So this is a radical molecule which abstract. So this is the isopropyl alcohol. If you see this molecule, CH3 CH isopropyl alcohol means 2-propanol. 2-propanol. Okay, so this 2-propanol, from this 2-propanol, the hydrogen, one hydrogen is transferred to this radical, on the oxygen radical. So splitting takes place. Then this oxygen radical abstract this hydrogen. So here is the hydrogen, the oxygen, and radical is as it is, and this is, and the isopropyl alcohol is converts to the new radical molecule. So the second molecule of this benzophenone, so I will show here A, because these two molecules are involved in this reaction. So this molecule again absorb the second proton from the isopropyl alcohol. Now in this case, the hydrogen is removed from the OH group. So this hydrogen is shifted to the oxygen. Now similar to this initial molecule, the again second ketal radical is formed, and this isopropyl alcohol is now converted into the acetone molecule. So in the last step, the ketal radical which is present in the second step and which is formed in the third step also, these two ketal radicals 1 and 2, they combine with each other through these radicals. Then there is a formation of benzphenacol. So this is the simple photoreduction reaction, conversion of ketone to the alcohol. So in this case the benzophenone is reduced to the alcohol and this isopropyl alcohol is oxidized to acetone molecule. So this is the simple photoreduction reaction of benzophenone to benzphenacol. So during this reaction benzophenone is reduced here and benzophenone is reduced to benzphenacol, whereas isopropyl alcohol is oxidized to acetone. I will write this reaction again here for your understanding. Now see here, so this is a benzophenone, pH COPH. So this is a benzophenone which is in the ground state. It abstract a light radiation, it goes to the singlet excited state, again it goes to the intersystem crossing, it goes to the triplet state. So now this molecule which is in the triplet state, now it gives a reaction. So see here, pH, carbonyl group, pH. So this carbonyl group already has 2 lone pair of electrons. So in presence of this isopropyl alcohol, CH3. For your understanding, I will write the molecule in simple format, simple structure. This is the second 2-propanol, CH3, CHOH, CH3. So in this step, which is in the triplet state, this molecule abstract proton from this isopropyl alcohol, so this proton gets splitted here and there is a cleavage of this carbonyl group also takes place. So pH, oxygen already has 2 lone pair of electrons. So due to the splitting of this carbonyl group, this carbon bears a radical, oxygen also bears a radical. Due to the splitting of this hydrogen from this isopropyl alcohol, I will simply write this as H radical, carbon radical, OH, CH3. So this proton radical, hydrogen radical, it shifts to this oxygen. So there is this hydrogen gives one radical and oxygen gives one radical, and this hydrogen is bonded to this oxygen now. So it becomes pH, this is a radical. Now this oxygen bonds with the hydrogen, it has already 2 lone pair of electrons. This is ketyl radical 1, ketyl radical is formed here along with the formation of this isopropyl alcohol radical. This is the radical. Then in the next step, again the second molecule of benzophenone, this radical pH, C, pH, oxygen having a radical. So this molecule abstract proton from the second hydrogen of this isopropyl alcohol. So this bond is get broken. This hydrogen now shifted to this second molecule of this radical. So there is a formation of pH, radical is there, OH plus CH3, radical and O radical. So finally, this molecule converts to this acetone structure CH3CO. Okay, so acetone is formed here. So the radical, this is the ketal radical, this is the second ketal radical. They recombine with each other. If I give the numbering 1 and 2, so this I will write here pH radical, I will write OH below, plus the same molecule is here. So these two ketal radical 1 and 2, they recombine with each other, and there is a formation of the final product, that is pH OH pH OH. So this is a benzphenol. So this benzphenol and acetone is formed. So here the benzophenone is reduced to this benzphenol, and isopropyl alcohol is oxidized to acetone. So this is overall the Neri's type. This is overall photoreduction reaction of benzophenone to benzphenol.